Humanity's technological journey has always been one of ambition, curiosity, and boundless imagination. From the invention of fire to the age of artificial intelligence, each leap has propelled our species closer to understanding and mastering the universe around us. But how far can we truly go? Could we one day become a civilization so advanced that we can harness the energy of an entire star? This tantalizing idea lies at the heart of the Kardashev scale, a method devised to measure a civilization's technological maturity based on its energy consumption. In this article, we will explore what it means to be a Type 2 civilization, the science and speculation behind achieving such a milestone, the obstacles that stand in our way, and whether humanity might ever attain this level of advancement. The Kardashev scale was proposed in 1964 by Soviet astrophysicist Nikolai Kardashev. His goal was to establish a way to classify civilizations based on the amount of energy they can harness and use for communication, exploration, and survival. The original scale includes three basic categories. Type 1, a planetary civilization, capable of harnessing all the energy available on its home planet. Type 2, a stellar civilization, able to harness the total energy output of its star. Type 3, a galactic civilization, controlling energy on the scale of its entire galaxy. These categories are exponential in nature. For example, a Type 2 civilization would use roughly 10 to the power of 26 watts, equivalent to the entire output of the Sun, while Type 1 is around 10 to the power of 16 to 10 to the power of 17 watts, corresponding to Earth's current total usable energy. As of the early 21st century, humanity is not even at Type 1. According to physicist Michio Kaku, we are around Type 0.72. We rely primarily on fossil fuels and have only begun to tap into renewable energy sources and nuclear power. Transitioning to Type 1 would require global coordination, sustainable energy solutions, and massive technological development. A Type 2 civilization would be so technologically advanced that it could capture and use the entire energy output of its star. To put this in perspective, the Sun emits about 3.86 times 10 to the power of 26 watts of power. Harnessing this amount of energy would enable such a civilization to power planetary-scale engineering, interstellar travel, and possibly manipulate planetary systems. Perhaps the most iconic idea associated with Type 2 civilizations is the Dyson sphere, proposed by British-American physicist and mathematician Freeman Dyson in 1960. The Dyson sphere is not a solid shell, as often portrayed in science fiction, but rather a swarm or cloud of structures, solar collecting satellites or panels, orbiting a star, capturing its energy. Types of Dyson structures: Dyson swarm, a collection of solar collecting satellites placed in orbit around a star. Dyson bubble, a system of statites or stationary satellites held in place by light pressure. Dyson shell, a hypothetical rigid shell, likely impossible with known materials due to stability and engineering issues. Constructing any version of a Dyson sphere would be an unprecedented feat of engineering. The amount of material required would be immense, potentially involving mining entire planets or asteroids. Transitioning from our current level to a Type 2 civilization is a massive leap, one that presents profound technological, socio-political, and philosophical challenges. To become a Type 2 civilization, we must first overcome our energy bottleneck. This means developing efficient and sustainable energy sources. Nuclear fusion, a long-pursued goal, fusion mimics the sun's power source and could provide vast, clean energy. Solar power. We must drastically scale up solar energy capture, on Earth and in space. Energy storage. Technologies like quantum batteries, superconductors, and advanced capacitors will be necessary to store stellar energy efficiently. Capturing energy from a star requires a spacefaring civilization with robust infrastructure. Megastructures, we would need to build and deploy millions of solar collectors in orbit. Self-replicating machines. To scale up, we may rely on autonomous robots that can replicate themselves and harvest materials. Advanced materials. Building solar collectors close to the sun requires materials that can withstand extreme heat and radiation. Constructing stellar-scale infrastructure will demand materials on a planetary scale. Potential sources include asteroid mining, extracting metals and other resources from asteroids, disassembling planets. In extreme scenarios, parts of Mercury or other bodies might be converted into building materials. Humanity is still fractured by national interests, economic disparity, and geopolitical tensions. Reaching Type 2 may require a level of global unity and collaboration that currently seems distant. Coordinated planetary governance could be essential. Artificial intelligence might play a critical role. The complexity of managing a Dyson swarm or even interstellar projects may exceed human cognitive limits. Superintelligent AI, possibly merged with human consciousness, could help manage such endeavors. How long might it take us to reach Type 2 status? Theoretical estimates vary, but many thinkers suggest a timeline of several thousands to tens of thousands of years. With exponential technological growth, it's possible we could achieve Type 1 in 100 to 200 years, and Type 2 in another millennium. This would require breakthroughs in fusion, space manufacturing, and artificial intelligence. Human self-destruction, via war, ecological collapse, or AI misalignment, might prevent any such progress. Some argue that achieving even Type 1 is not guaranteed. Are there any Type 2 civilizations out there? This question is central to the field of astrobiology and the Fermi paradox. If advanced civilizations are possible, why haven't we detected them? Astronomers have searched for infrared excesses in distant stars which could indicate the presence of a Dyson sphere re-radiating waste heat. So far, no definitive evidence has emerged, though some candidates like KIC 8462852, also known as Tabby's star, sparked brief excitement. One explanation is the Great Filter, a hypothetical barrier that prevents civilizations from reaching advanced stages. This could be the difficulty of life forming, the leap from single-celled to intelligent life, self-destruction due to technology, or the limits of physics or materials. If the Great Filter lies ahead of us, reaching Type 2 may be impossible. The journey to Type 2 is not only a technical one, it challenges our understanding of civilization, ethics, and purpose. Abundant stellar energy could eliminate resource scarcity, enabling a society where material needs are fully met. What would economics, politics, or culture look like in such a world? Altering planetary systems or stars could have unintended consequences. Would we have the wisdom to wield such power responsibly? Even Type 2 is not the end. Type 3 civilizations could roam and shape entire galaxies. Beyond that, some speculate about Type 4, universal, or even Type 5, multiversal civilizations. While a true Dyson sphere is far off, steps are already being taken toward a space-based energy future. Agencies like NASA and JAXA have explored the feasibility of space-based solar power, where satellites beam energy to Earth via microwaves or lasers. Companies like SpaceX, Blue Origin, and others are rapidly reducing launch costs and laying the groundwork for large-scale space infrastructure. Though in early stages, ventures like Planetary Resources and Deep Space Industries have proposed asteroid mining as a stepping stone. The dream of a Type 2 civilization is both awe-inspiring and daunting. It challenges our imagination, our technologies, and our moral compass. While reaching such a level seems almost mythical today, it's not outside the realm of physical possibility. The universe is vast and the energy of stars is abundant. Whether we can organize ourselves, politically, technologically, and ethically, to reach such heights, is the real question. The journey toward Type 2 is not merely a matter of harnessing stellar power. It's a test of whether humanity can transcend its limitations and become something greater, a truly cosmic civilization. The stars await. The question is, will we rise to meet them?